equations. So here we're going to work on and use 4 steps to solve more complex linear equations. We're going to solve equations that might have no solution or an infinite number of solutions. We're going to work with fractions and decimals and write expressions with 2 related unknown quantities. So if I want to look at the 4 steps for solving an equation, here are the steps. I want to clear out parentheses, fractions, decimals, and combine like terms first. Then I want to get the variable alone once all of those previous steps have been done. To isolate the variable, you're going to do the opposite of what has been done until you get just the variable. Then you will check your answer. Because these are graded assessments, it's really important that you always check your answer. So here I have no parentheses, nothing to combine like terms, no fractions, no decimals. So I go straight to isolating the variable. When I'm isolating the variable, addition or subtraction comes first. So I need to subtract 4 from both sides. That gives me negative 5p. That's negative 5 times p. I'm going to divide both sides by negative 5, and I get that p is negative 3. I'm going to go ahead and check my work by substituting that in. And I find that it is true. So I know that is a solution. Here, I have extra terms. I have x's on both sides of the equation. It is up to you on what you want to combine or move over. I moved 2x over, but you might choose to move the 8. That's fine. Negative 8 minus 2 would be negative 10. Now I can move the 5 to the other side. It's a positive 5. So I'm going to subtract. Then I have negative 10x equals negative 10. The inverse of multiplication is division. And then I simplify. So you want to remember that the variable could be on the left or the right and be isolated. There's multiple pathways to get to your end destination, just like if you were driving somewhere in your car. Here, I have to get rid of the grouping symbols first. The first thing I'm going to do is distribute that 3 to each term in parentheses. Once I have that done, I'm going to go ahead and complete the multiplication, and then I'm going to think, well, do I want to move the 3x to the other side, or do I want to move the 5x? And then I can combine 11 and 3 to get 14. So which way do you guys want to go? You could go either way. I would subtract 3x from both sides to avoid negative answers. So 5 minus 3 is 2. Then I would subtract 16. And then I would divide by 2. Again, you could go a different way. You could move the 5 over. That's okay. Here, I want to distribute that negative first. That means everyone is multiplied by negative 1. I want to combine like terms. 4x minus x is 3x. Then I have to move over the 7. Addition or subtraction comes first. I add 7 to both sides. I divide by 3. And then I can check to see if it's a solution. Be very careful with signs with equations like the previous example. A lot of students want to drop that parenthesis off automatically because they don't see a number. Remember, subtraction works like negative 1 times the parentheses. That's the most common mistake, is that this negative gets dropped off. So the first thing we're going to do here is use that distributive property to distribute the negative 3 and the positive 4. Once I do that, I'm going to combine this 2 minus 6 and 4 minus 8. Once I have that done, then I can leave the discussion of, am I going to move the 18 or the 4 over? I moved the 4. You could move the 18. It doesn't matter. Negative 18 minus 4 is negative 22. Once I get all terms combined, then I do addition or subtraction. Negative 4 would be adding 4 to both sides because that's the opposite. Then I get negative 22z equals 0. I divide both sides by negative 22. This is not undefined, okay? Undefined is when you have 0 in the denominator, not when you have 0 divided by something. So what you could then do is plug in to determine if 0 is accurate as a solution. Now, if I have no solution or infinitely many solutions, let's take a look at what that looks like. So far, we've had one solution for every question. An equation with exactly one solution is what we call a conditional equation because it's only true under that one condition. But sometimes there may be no solution or multiple solutions. So let's take a look at tackling that. The first step here is to combine my like terms. I have 3x minus x. So I'm going to do 3 minus 1, which is 2. And then on the right-hand side, I have negative 4 plus 14, which I can combine those to be positive 10. Now what you notice is I have 2x plus 10 equals 2x plus 10. That is a distinguishing factor because what's on the left and the right-hand side of the equal sign is the same. Let's watch what happens as we begin to solve. I subtract 2x from both sides to try and combine those, and I get 10 equals 10. So again, I have the same thing on the both sides of the equal sign. And if I kept solving, I would wind up with 0 minus 0. So this is a unique situation where the solution is all real numbers. How do I know that it's going to be all real numbers? Well, in the future, when you see the same thing on the left and the right-hand side of the equal sign, that means that it's always going to be all reals. Let's see what happens now with no solution. So the first thing is we're going to distribute that 6 to each term. Then I'm going to combine my like terms of 6x minus 3x, which is 3x. I don't have the same thing on the right and the left, but I have something similar. So what's going to happen is we combine those 3 x's. Well, I need to get all the x's on one side, so I subtract 3x and look at what happens. When I subtract the 3x, it cancels on both sides, so I have 8 equals negative 6. That's never going to be a true statement. That's always going to be false, so there is no solution. And we can use that by saying no solution, or we could do the circle with the cross through it. Now we're going to do the same thing, but with fractions or decimals as coefficients. So, how do I get rid of those fractions? We always want to get rid of fractions. We multiply by the least common denominator of all fractions in the equation. This will make your problem completely work with integers. So I look at 3, 12, 4, and 2. What is the least common multiple of all of those numbers? It happens to be 12. So I multiply every single term times 12. When I do that, I'm going to have some cancellations. The 12 will cancel with the 3, and 12 divided by 3 is 4. 12 divided by 12 is 1, so I just have minus 5. 12 divided by 4 is 3, so I have 3 times 3, which is where the 9 comes from. 12 divided by 2 is 6. Now that I have all of these fractions cleared out, I can actually think and process the problem. I need to get all of my x's on one side. So I subtract 4x from both sides. Now I need to move the 9 over. 9 is positive, so I'm going to subtract 9 from both sides. Last, I'm going to divide both sides by 2, and I get x equals negative 7. All right, here the instinct for a lot of students is to go ahead and distribute. That is not what we want to do. We first want to clear out the fractions. I would not follow these steps. So I'm going to walk you through what I would do. I would do the least common multiple of 4 and 3, which is going to be 12. So that I would have 3 here and 4 here. And then this would be negative 24. Then I would go ahead and distribute. The problem, the book wants you to go ahead and distribute first. Okay, that's doable. We can distribute first. Then we're going to take care of that 12. So basically what I did was skip this intermediate step because I multiplied by 12 to start with. 3x minus 8x is going to be negative 5x. 9 minus 8 can also combine, so we have multiple like terms. Then I'm going to subtract 1 from both sides and divide by negative 5 so that I get x equals 5. So a lot of steps here, and you could multiply before you distributed. The textbook examples and the lab will probably show you the distribution of that fraction first, but it is possible to do it second. Here they want you to clear the parentheses, so go ahead and distribute. If you don't know what negative 0.5 times 2 is, use the Web 2.0 calculator. This is not where someone's looking over your shoulder to check your work. You can definitely utilize the tools within the course. So now I need to get all of my like terms combined. So 4.5 minus 0.7 can be combined on the right. When I combine those, I could do that subtraction first. Again, we have multiple ways that we are able to go. And I'm doing, then I can multiply by 10. Or, as the book says, I can multiply everything by 10 to clear out the decimals at this point. Either way, doesn't matter when you do the multiplication of 10. Do you have to multiply by 10? No, you don't. You can still work with the fractions, but the decimals. Most of us don't like seeing those decimals though, so we can go ahead and get rid of them. So now you would do 45 minus 7, which is the same thing as if you did 4.5 minus 7 and then multiplied by 10. Now I'm going to get all of my x's on one side. It's a lot easier to add 1x than to add 15 to the other side, but you can do it either way. Subtract 10 from each side. I still have a negative 14. I've got to divide, and I get negative 2. Then you can always plug back in to make sure that it's a solution. Now here is where we get to have a relationship between two different variables. I have two numbers have a product of 36. So that's two different numbers. So I would need two different variables. If one of the numbers is represented by x, find the expression for the other number. So where does 36 over x come from? Well, if I have 1 as x, my other number I'm probably going to call y. So I have x times y equals 36. If I want to solve that for the other number, that would be solving for y. So I would need to divide both sides by x. So I would get that y equals 36 over x.